Okay, well, thank you so much for coming. My name is Luis-Daniel Ibáñez. I'm a lecturer at the University of Southampton. I'm also a member of the Center for Machine Intelligence, and Jaime already explained what it is about. So I also have come with that hat. And finally, I also come with the hat of the OPCAS project, which is an European Union's Horizons Research and Innovation Action, which partially forms part of some of the things that I'm going to show you here. Okay. Good. So who I am, long ago I was in France doing my PhD, mostly about distributed databases and semantic web, that kind of combination. Then in 2015 I came to the UK at Southampton, where I worked in a number of projects about open data innovation, big data management, crowdsourcing, a bit all around the place. If you've been in, a bit like a company, you go where the money is, right? Someone finds the money. Hey, I need a research fellow to work on this, and say yes, okay, I need the money. So that's how I sort of went working a bit in several things. But that's a good thing, because then later in your life you have a lot of things to do. So since 2020 I was promoted to lecturer. Okay, so I also do teaching, and I'm also a member of the CMI. Right. So where is dataset search there? How I became interested in the dataset search problem, because as you can see in my previous background, there is not much information retrieval. So how I ended up doing this. So while I was a research fellow, I was involved with a project called WD Aqua, which was about question answering on the web data. And this is something where question answering is connected to information retrieval. It was a very big project, one of those called, I think it's Marie Sklodowska-Curie, the ones that train PhD students, right? So I was, in fact, working with one of the PhD students that was particularly interested at the dataset part of it. That was my first contact with it. I also had the opportunity during a time to work for the European Union Open Data Portal, that now it's known as data.europa.eu. So they were trying to create a portal for accessing all open datasets, mostly open government datasets, and also they have a lot of geospatial information, which is this kind of public data, public open data that they were, and they're still trying, because that's still ongoing effort, and make it findable for people to reuse at most levels, or to the industrial level, to the other levels. I also work with federated and decentralized querying for my PhD, so that was another thing. They say, hey, you have multiple repositories everywhere, so that's something, hey, this is a kind of problem that I've been working before, so I can do it. Okay, product-wise, where is dataset search? This is something that has become recently a trend, something called data catalogs, that I imagine in industry you have heard about them. So data catalogs are products that organize your enterprise data. They're mostly for, they sell themselves to companies. Hey, allow me to organize the data sets that you have, your data assets, as they call it now. Okay, that provides, allow you to give an overview of data assets. This for product managers and the management layer, and also contribute towards the implementation of effective data governance, which is also a concept that in industry it start become very important. Hey, how you are governing your data. If you don't have it cataloged, if you cannot find it, if you don't know what you have, then there is you don't achieve governance, right? The catalog on its own does not achieve governance, but you do need the catalog to get into the governance part. And there are many products, right? And they say, enough to warrant a Forrester Wave 2022, okay, which is one of these consultancies that orders them in how mature they are. You probably know more than me. Apparently, the better you are here, the closer you are here, the better. And I think, yes, I took this image from this company side. So they want that. This is the blue line. That's the blue line is not me, it's this company that say, hey, we're here. Okay, so I'm also, I took the image from them, so I have to do them the service that, yes, they are here in the good corner, right? Very well. Okay, now quiz time. Yes, because I'm a teacher, I cannot, refrain myself from asking questions like this. So anyone recognizes this diagram here? Yeah, this is the part that I lost with the PDF, because now this is here. The magic here is that maybe you recognize it from this book, which is a classic book in information retrieval. I imagine many people have read in the life. Okay, and this is just a representation of the general process of information retrieval, in this particular case for documents, right? Which are the ones that, we started doing that. Now we do many other verticals, as we saw with Jaime in the image vertical, and there are many others, but this was kind of the start. But all this, let's say, boxes or components, remain. You need a visual interface, you need some sort of indexing, you need to have some sort of ranking, you need something that guarantees the searching, and you also need some query operations that are usually attached to the visual interface, right? The visual interface allows you to construct a query in whatever language, and that you apply on your index and the ranking that you can produce on that index, right? So in dataset retrieval, of course, we can apply the same general model, but instead of text, we have data sets everywhere. Okay, so what is different, right? If I said that this, let's say, maps to the general model, right? What is different with a data set? So the first thing that it's different is the precise definition of what a data set is, because sometimes it can be an item, a type of item that we already know how to handle, like textual documents or images. But it can also be a combination of alphanumeric data. And in fact, when I started working on this, already that will be like 4 to 5 years ago, the new thing was the alphanumeric data. You were doing documents, but now, hey, you have tables, you have things that have numbers inside. You cannot search those numbers in the same way that you search text. Okay, so what do you do? So, and potentially you also have multiple formats, right? You may have a relational thing or a tabular thing. That will be the most common kind of thing, but now you can have graph with machine learning kind of things. You sometimes have, Parquet files, stuff that are meant for execution machine learning pipelines. So, a much more heterogeneous kind of bag of items or set of items, right? So this would be one of the first difference. The second difference, as you know, from information retrieval, you always have to model your users and your tasks for whatever you are doing. So in terms of dataset search, the users are normally people that work with data. They can be data analysts, data scientists, and if you want to go a bit beyond the technical part, you also have data journalists, or people that it's not, let's say, I would say not computer scientists or not statisticians or people that like that, but people that need data for something else. Okay, so they either need data sets to perform a particular processing, which is what in this table here, that it's not mine, it's from this paper here, that it's a very nice paper it's from our team as well in 2017. You can be goal or process oriented. So you are collecting the data, you are searching the data for a particular task. Okay, but here through user, they did it was a user study, the methodology for this, with people that worked with data at different levels. So some processing types are common. Okay, so at that time they were talking about linking. I need to for this because I need to establish a link between multiple data sets, maybe that I haven't found, or one that I already found, and I need to establish links with something else. You can also have, and these are the more like for journalists or an analyst, like summarize. I need to produce a summary of something, and I need data to summarize. I need to do a presentation. Right, I need to present some data, or I need to export. In this case, it's more of a data transformation. At that time, and I think because of a bit of how to say, population bias, I'm going to talk it for the user study. They only consider time series analysis as a thing. But to me, this is more, I think nowadays, we can probably do some kind of machine learning model would be a more common type of thing than doing a time series analysis. We can at least add, I need to train a model and I need data to train that model to this diagram here. That's something that I would add. It's not in this study, but in more recent studies, I think that the direction is that way because it's a very common task. Right. So yeah, we're in the users and task. I also here for the purpose of this talk, I also extracted some of what I believe are the dimensions of the dataset discovery, of dataset search. This is of course non-comprehensive at all. There are many more, and there are many surveys that I can point you later that have much larger, much broader taxonomies. But for this presentation, for the time that we have, I want to pay particular attention to the query type, right, which maps to the query operators and the visual interface that we saw in the let's say the fundamental diagram from the modern information retrieval. The heterogeneity, right, the heterogeneity of your repository of items. And what I call, and this is the new part that we are sort of looking at the OPCAS project, what I call the contextual dimension, right? Which is beyond search. What are you going to do with that data set? So data sets may have usage control or usage policies attached to them. They may also have prices if you are selling them, okay? They also nowadays, because of the importance of green technologies, they also have environmental footprints, right? And there's also negotiation, okay? And I will talk later about the concept of a data marketplace, which is a place where search is the component, but that then leads to these contextual dimensions. But before all that, let's talk about the more, let's say, ground things. So I would like to just give a quick review about the query types and what is different. Right? In the same way that we saw with Jaime, that you have either keywords or you can put an image and do some image search based on the image or do some kind of multimodal. Here, more or less the same. You can have your classic keywords and facets that we all, know and love, right? As, an Amazon thing. To me, this is, you see a data set as a product in a kind of a store. Okay, and then you mimic exactly the same kind of interface that you have for products. So you have your text box to do keywords, okay, and you have a number of facets here, okay, for filtering, right, the categories, and you can also sort by relevance or other criteria that you have here. So just the regular thing. And each data set, the 10 blue links and are everywhere. Here is a blue link, and you have a snippet of the data set. Here it's more about the provenance. This is from the Data Europa portal. So this is a data set that comes from the Open Government portal of Belgium, and it's available in this format. This perhaps is the two things that they're not directly, it's not something that you will see in a product, or you will have to do some sort of mapping like, maybe this is the origin of the product and this is, the colors on which the product comes. Okay, that's sort of the analogy, but nothing new here. We're just trying, this is the metaphor that people understand more. So the first efforts were towards that. Okay. So approaches to solve this. So if textual descriptions are available, then it's a relatively easy problem to solve because you consider those textual descriptions as textual documents. You use Solr, you use Elasticsearch, all those things that Alessandro can teach you about, right? And will, and yes, we plug their trainings that are coming soon in December. So yes, you solve it like that. Of course, the big problem sometimes is that you don't have those descriptions, because at least, and we had this problem with open data, right? When it's a product, the person selling the product is very interested that the description of the product is very well, because they're selling, right? Their survival depends on it. Now, for a data set, especially an open government data set, maybe there is some intern that says, hey, we need a description of this, right? And they put whatever they can, okay? And that may be not the same. The other issue that we found with data sets is that contrary to a product, like, I don't know, a hairdryer, it's very clear what a hairdryer is for, okay? To dry your hair. So people looking for that wants to dry their hair. Now, people looking for a data set, perhaps demographic, let's say London population segmented by borough. Okay, you're not sure what they want to do with that. So you don't know what is the best description, because maybe that can be done for linking with another thing. Maybe that's done for a summary. Maybe it's a data journalist. So you cannot tailor your description to a use case. So that's a bit of an issue when you are using them. Okay. So if you don't have them, you have to generate them. Either you have to crowdsource these, and that's where my crowdsource experience came handy. You can have, for example, multiple descriptions, try to collect multiple descriptions and have some context, yes, for each description that you can add to the query. Previous pre-LLMs, right? Because this was before the LLM revolution. People were doing this mostly to help with the evaluation phase. As you know, in information retrieval, you have the ranking there, and then there is a phase where the user has to evaluate, was this what I was looking, yes or no? So this description was mostly for that, but now with LLMs that maybe help us to generate these descriptions, right? So it's now research direction to evaluate if LLMs make this more appealing. By appealing, I mean, can I use the ChatGPT Blood to, hey, generate me a textual description of this data set, and then I can put that into an index instead of getting through all the pain to crowdsource them or training the poor intern to do it right all the times for all the context, right? Especially for this context thing, because now with the ChatGPT, hey, do it like this way with this tone or for this persona, so you can generate those more easy. So that's a nice, an interesting direction that will increase, because this is like a baseline for many others approach. But if now you can do this baseline becomes a bit stronger, right? So there is this, let's say, potential here, okay? Just a quick parenthesis here about the approaches for this. This is just a data model. This is a W3C recommendation for a data model to describe data sets and data catalogs. Okay, I'm not going to go into details with this, but this is something that is very established, and at least all the government catalogs and public catalogs use this. I think if you go to private thing that goes to enterprise data, they don't necessarily use this because it's more for the scope, it's different. But this is something that I felt it was important to mention its existence. Now, in terms of approaches to generate, we saw about the descriptions, right? One part was the description, but now I can talk about the facets. So one approach to do the facet generation will be the same that you will do for a product site, right? You ask your users, you monitor their click streams, you set up all those nice things, you set those facets, you keep monitoring, and then if you need to, you change that facet. Okay, so that's like the regular. Other approaches that research that are quite nice, they try to generate the best structure for navigation. So you have a bunch of data sets and a bunch of labels about those data sets of categories, right? And you're trying to move from this part from the upper diagram here, the upper categorization, let's say, or taxonomy of your data sets into something that is more efficient. Okay, and there is let's say there is a definition of efficiency, right? So I'm not going to go into the deep math of that, because it's, of course, if you're interested, it's a Markov model, right? So they model that in a way, what is the probability of drifting off and all that. That's the core of it. I find the easiest way to understand this is that you need to strike a balance between depth, because if it's too deep, it's not very efficient if the user has to go deep to find something, and number of branches of each step. If I go in a step and I have 20 branches to go, that's bad from a user perspective. So you sort of need to balance that. And they try to do this automatically. So you say, hey, here is my repository, here are the labels, what is with each label, and returns the diagram that is most navigationally efficient. By facet, do you mean a kind of semantic index? No, by facet, I mean a filter, like the filter of the thing. You can also do that category. I think that will be another potential word that is more, I think facet, in papers they call it facet a lot, but I think very few people call it facet for, they call them filter or categories. I think they're both. Facet is used.
I used to do search stuff with Solar, so I call it facet.
Okay, yeah, maybe I think because, yeah, we didn't do in the CCAN mostly here, that I know has Solar inside. So yeah, I believe they take the terminology from here. Okay, so this is what you can do to generate this product store, data store kind of thing. Now, beyond that, as we saw, the data scientists and data analysts have more particular use cases than just exploration, right? That let me find that. And one of these is what we call the query by table. Okay, so you give, instead of giving keywords or start filtering, you give the system the actual table. Hey, this is the table that I have. Can I get tables related? This, of course, I'm using the example of tabular data because it's the most easy. You could generalize this to any other format if you want, but most research is in terms of tables. So instead of it's like the image search. It's like the analogy of the image search, but instead of giving you the image, I'm giving you the full text. Hey, find me something related to this, because then if you are, what was the logic of this? On one interface that I saw what's quite cool, if you have a Jupyter notebook and you have a frame and you have a snippet of your table in a frame, you have some sort of contextual button inside the Jupyter notebook that says, hey, in my repository, open data or corporate data or whatever, and you find me things that relate to this. Okay, so that's quite nice for this data science use case. Similar use case related to this one is the cell auto-completion. I have the table is missing some cells, and I say, hey, what goes into this cell here? The thing goes down and tries to find the thing that potentially can go there. As you can see, this is the envisioned user interface of this approach. You can have several kind of things. I'm not sure. I know that now LLMs, again, this is all pre-LLM. Now with LLM, I know you can summarize very well things into tables, but I believe it's mostly the formatting, right? We're not sure how it works inside, right? So it's very magical in that way. That, oh, I asked the table, then there is a table back. I'm not sure how would it work connected to enterprise repository, but I do know, for example, some of the companies that do data catalogs that are actively trying to find that, because that will be a very, very interesting value proposition for them, right? For me, at the moment, I'm a bit more of skeptical into that. Maybe I will be proven wrong. At the moment, the LLM can do very well the translation from natural language processing to this query that it's, oh, I need a table from here. Okay, so at least you you save yourself that step. However, if we consider the visual interface that I explained to you before, when I'm doing this in a notebook, I really don't need this, because I already have the table there, and it's easier for me from a user perspective to say, I want something on this table that I already have here. I really don't need to write you anything. So that really will depend on the final use case that we have here. Okay. Finally, there is the concept of table augmentation. So I have a table and I need to find things that either union, more rows, more columns, or add to that subtable. Okay, so here we go closer to the database people, right? Because this goes to joins and unions, especially in tabular forms, but of course, in any other data representation, there will be a database person saying that they can do that. So we are in this particular approach, the techniques used here are closer to what you would see in database kind of, or data management kind of things. Right. So that was just an overview of the query types that we can find in dataset search. I just have one slide about the heterogeneity, right? Also, some people know, and I'd like to, again, as I'm one of those database peoples that it's now, transitioning towards here. What is the level of schema aligned? So you have your data repository, right? And if you have everything aligned to a schema, then you have some sort of a data warehouse, and you don't have to do anything mysterious, right? You have a query on that schema in the whatever language that you like. Done. That solves your retrieval problem. Okay, so the thing is that now with all this big data and lots of data sources coming from everywhere, many times you don't have the time or the resources to construct a giant warehouse. So you have data that is not integrated, and you sort of integrate it on demand. This is what I think in industry and in research as well, they call the data lake, okay? Because you just put things there that not necessarily are integrated with a particular scheme, okay? In any case, as you probably know, because this is nothing new that I'm going to say here, it's all about the effort or the balance between, or the effort balance between Either you have the data and you have to crowdsource or hire people or do something very complicated to align to a certain schema, so you can query onto that schema, right? And this, I think, is common both in IR and in databases. Or you start throwing computational units at the problem, right? Whether they are LLM computational units or more traditional computational units. So that's kind of the balance that one is trying to strike here. Okay. Now, just wanted to say that now move to the contextual dimension in terms of the data spaces, right? Because in the beginning of my talk, I mentioned the data spaces, which is kind of the new thing. So a data space, it's a vision that they have at the European level, part of their European strategy for data, okay? So this is just an excerpt of their definition. The core part here is that this bottom here, common European data spaces will ensure that more data becomes available for use in the economy and society, while keeping the companies and individuals who generate the data in control. So you go a bit beyond, right, the enterprise data catalog, and you want to be able to do a search that it's a whole space of people generating data. So you would like, for example, if we want to need some data that is published by someone else, we can find it quickly, not necessarily within our own scope. Okay. Now, this is a complicated slide. I think just the top one, it's important for what I want to have in the let's say the European view for this. They decided, and this is a consequence of the schema alignment problem that I said earlier. You know, you cannot do the full data space where nothing is aligned with nothing, because then it becomes very difficult. So they decided in a number of sectors. So each sector, health, manufacturing, agriculture, mobility, they are of course strategic sectors for socio-economical, political reasons. But it also allows everyone to say, hey, each of these can have some sort of schema, even if it's at a loose level. So things inside here can align to that, and it's easier to find. So we sort of have this compromise instead of having the one data space for all, where there is no alignment with everything, because they expect that become too complex. And at the beginning, when I heard this is a why those, why that, I don't think that works. But then I finally clicked, of course, because if you don't have at least some kind of alignment, you're done. Right, and based on that, or a derivation of that, is the concept of a data marketplace. Is an instance of a data space where the exchange, right, when you are exchanging data with someone, this is economically driven. Okay, there is money on the table. You are selling data, selling your data assets. Now, from the data catalog, those have a value for your company, but maybe now some of those you can sell to others, right? They have an economical value. There are different business models for this. There are some marketplaces that sell you the brokering. Hey, tell me what you want, the finding part, the information retrieval, right? Hey, what do you need? You need something for this, for that? Yes, let me talk. Yes, this is the person you need to talk about. They also sell you the intermediation in some cases. Hey, you don't want to share everything. You don't want to transfer everything to here, everything to that. I'll be your middleman, and you can trust me because I am a big brand, or I have a number of technologies, okay? Or this one, which is for the big ones, they sell you the computing power to do the processing, right? The marketplace is a bit of, you're buying data. That means you're processing some data. Do you need cloud to process that data? Because I have lots of clients, right? But this is what, the Azure marketplace or Databricks try to do. Very well. And so this leads to the contextual dimensions, which for us is, where is the data located? Who has permission to generate the data set descriptions, for example, and use them? What are the data set usage policies? What are the pricing policies of that? And I just want to point out that this is a generalization over the enterprise data catalog, where the company owns everything and you are not selling, you're just transferring to another department, right? And of course, that's quite interesting. But then you are extending. Before we had up to here, find me a data set that something, or that, joins with a table or unions with it. But now you add some things like that I can afford, that I can use with my processing purposes, which becomes more and more important with data protection and all that. That it's someone that is open to some kind of negotiation of the terms of usage. Okay, so you add that contextual dimension to the search, right? And just quickly, there are a couple of approaches to the data marketplaces. This is a very smart person from Chicago University. They have I think that the most important thing is that this is like centralized. They call their approach like a data escrow. Okay, so the data marketplace has access to everything and do all the, you know, all the processing. So, well, they have a pricing engine and, you know, packaging. The only thing that might be, or we add here, is the WTP, which is an acronym for willing to pay. So part of your query, before we saw this query, find me that I can afford. So part of the query now, it's a function that is how much I'm willing to pay for this particular data set. And that is part of the search engine that it's about here. And of course, if this is something that it's also selling the intermediation, it has a revenue thing, okay? That if you are a seller, you are selling that service to the seller. I'll get you the buyer that gets you the more revenue. Okay, it's somehow. So you have this kind of additional things. In the project that we do called Opcas, in terms of the marketplace, we would like to be a bit more flexible if required in terms of where the data is located and processed. Because in the other approach, everything needs to be, you need to give full permission to the marketplace to do all the wonderful things that they can do. Okay, but sometimes, especially with this data protection and, you know, usage constraints, you cannot do that. So for us, we want to be a bit more general than that and to enable federated and decentralized approaches if required. And if you don't want to be, you know, that disruptive and say, yeah, we don't like decentralized bad actors, ultra companies doing that, you can simply consider the use case where you are buying data that is in two marketplaces. So one is in Databricks, one is in Azure. You want to, I want to buy from there. How do I do, right? Do I need to ask someone, hey, no, you need to go into Databricks and sell your thing there so I can buy it, right? That doesn't make sense. So this is something that we would like to support. For that we have, well, it's a much more complex than discovery. In fact, discovery, as you can see, is this little number 5 here. This is the place. Before that, first the dataset owner needs to do the description. Okay, so there you have to have things to describe, you know, the textual description, what we saw about the facets, privacy, usage control, pricing, energy profile, etc. And then when it's discovered, then data processing workflow is what a consumer wants to do with it. And then depending on what the consumer wants to do with your data, then you can negotiate, execute the transfer, do integration if it's needed, and monitor if that's being executed somewhere, okay? Independently if it's that, you know, on Databricks, Azure, or if you have some sort of federated machine learning engine, okay? From a resource consuming perspective, then you are searching. We assume this task that I said at the beginning, we need data for a particular processing pipeline. If you want a machine learning pipeline or a data science pipeline, including the intentions, then this is where the search part is. Now find me data that I can afford, that it's compatible with my intentions, or that I can negotiate to make compatible with my processing intentions. And then, well, these are the other parts like evaluation of constraints, negotiation if required, and things that are extra search, but now are that contextual dimension that I mentioned before on the search. So in summary, I provided just an overview, a bird's-eye overview of dataset search and discovery, which is now a very hot topic. Even now it's moving even to machine learning models, right? Because as I mentioned before, nowadays data, especially in big companies, you are buying it for training models. So now the next step is to sell the models themselves, okay? So this introduced new challenges with respect to documents or product retrieval, notably the dataset heterogeneity. It's not just text as before. You have alphanumeric data or very heterogeneous kind of stuff. And you have query types that are beyond keywords or facets of images, like all the tabular examples and query by table kind of examples that we saw. And if you go one step further and go to this concept of space, marketplace, you want to create this kind of additional sharing, then the search dimension, the retrieval dimension gets these contextual dimensions of usage constraints of what you are looking for, pricing of what you are looking for, and openness to negotiation. And that's it for me. I'm happy to take any questions.